in the last series of videos, we have seen like how to solve differential equations using the matrix method by the help of eigenvalues and eigenvectors. In this series of videos, we'll be looking at few examples and also at the complex eigenvalues and how to solve them. So let's begin. So I'm going to start off with a pretty straightforward example. Let's consider an x vector prime is equal to a x vector. So this has been given in the question. So it's of this form where we are given that a is directly -1, 4, half and -2. So this is the question. So now it's pretty straightforward. If this matrix solves the differential equation, if this matrix is part of the differential equation for x prime is equal to ax, then we need to find x of t. What is that? So we're going to solve this. So as you remember, the first step would be getting the determinant of a minus lambda I and then equating it to 0, right? So a minus lambda I would be -1 minus lambda, 4, half and -2 minus lambda is equal to 0. So I'm going to expand this thing now. So I'll be getting -1 minus lambda into -2 minus lambda minus 4 into half, that'll give me 2 is equal to 0. So when I just rearrange these terms, lambda plus 1 into lambda plus 2 would make it lambda squared plus 3 lambda. You get a plus 2 over here and then you have a -2. So that's going to go away and we get it as 0. So we have lambda into lambda plus 3 is equal to 0. So my first value for my first eigenvalue is 0 and my second eigenvalue is -3. So we know that when we have a 0 eigenvalue, we'll have some special behavior in the graphings, right? So now we need to find the eigenvector for this. So it'll become a minus lambda 1i would be -1, 4. I have a minus lambda 1i when I just fill this in, and if I have an eigenvector for that, I'm getting a 0, 0. So if I'm multiplying this column by 4 and then taking this column as 1, then I'll just get 0. So my first eigenvector would be v1 is 4 and 1. So I'm doing the similar thing for v2. When I plug in my second eigenvalue in a minus lambda I, I'll get this matrix times my eigenvector has to give me my 0 vector. So if you look at it, if I multiply this column by -2 and just add it with this column, I can get my 0 vector, right? So my second eigenvector is just going to be -2 and 1, or 2 and -1. So I have this one, so I can come about framing my answer. So my x1 of t, my first vector, would be e to the lambda 1t times its corresponding eigenvalue v1. So that'll be 4, 1. And my x2 of t would be e to the lambda 2t and its corresponding eigenvector, right? And my final solution to the differential equation, that's x of t, would just be a linear combination of these. So c1 times 4, 1 plus c2 e to the -3t of -2 and 1. So this is the final answer for the differential equation.